question 25 says for function f of x is equals to mx plus c, we have that the first derivative when x is equals to 3 will be 0, and that the function value evaluated at the value when x is 0 is equals to 2, which is quite wordy and even looks weird in the maths, but it's something that we can do. So since we know the coordinates of the inverse of f, which is this inverse, not the derivative, if I say derivative earlier, this is the inverse of f. So since we know those coordinates to be 0 and 3, we can, well, the coordinates are actually for the inverse, it will be 3 and 0, but since we are looking for the gradient of the original function, then we need to invert the coordinates to give us that. So these are the coordinates, and then we can substitute the second part to get the equation using this. So we know that f of 0 will give us 3, because this is our function. We know that at 0 we get a value of 3, and we also know that at 3 we get a value of 2, because this is our function. If we substitute f of 0 as 3, then our answer here is going to be 2. Then we can use these coordinates as well to get values of our gradient. So our gradient needs 2 coordinates. One of the coordinates, we got them using this information by just inverting that. Then by using that information displayed on this function, we can substitute f of 0 into this, which would give us f of 3, which then reveals another pair of coordinates. So then using these pair of coordinates, we have 3 minus 2 all over 0 minus 3. This is going to give us 1 over 3, and yeah, that is our gradient, and that corresponds to D.